All right, so let's go ahead and take a look at the first problem. Hopefully I've written it correctly. So here I have these log rules. So log rules are rules that basically I believe you're assumed to have known to know. But here they are. Basically, log rules apply to natural logs. The thing that looks like a little ln. So here we have this. I just want to mention that ln x equals y is the same thing as saying log base e of x equals y. So ln is the same thing as saying log with a base e. So basically these log rules right here apply to the natural logarithm too. So let's go ahead and try to apply these rules. So I went ahead and I copied it and I color coded it to match here. So we take a look at our rules. We see where we see a minus sign between two logs, and I find it right here. So from here is equivalent to going to here. So this is minus, so we're going to combine it into 1 with a division as rule 2 says. So this is what that looks like. All I did was use rule 2. Great. Now we have the natural log of this stuff equals 2. Now, I gotta get rid of this natural log if I want to solve for x. The goal is to solve for x as the problem says. From here, I'm going to use Rule 7. Rule 7 says to get rid of a log, you raise it to its base power. So as I mentioned before, a natural log has a base of e. That means to get rid of this natural log right here, we're going to raise both sides to the e power. Let's go ahead and do that. Great. I raise both sides to the e power. When I do that, this whole stuff will come down by itself. As Rule 7 says, when I raise it to the base of the log, the k, the stuff in the parentheses, just comes down. So this stuff is going to come down. It's going to be free. And over here, you still have e squared. Good. The goal still is to solve for x. I have a problem, though, because I have an x here and an x here. We got to separate them and then bring them back together because it's problematic that they're in two different spots. So here's a technique to use when you have this situation. Multiply both sides by x minus 1. This technique will get rid of this x here because it's on the top and rid of this x here because it's in the bottom. And on this side, let's go ahead and distribute e squared into the x, and don't forget to distribute the e squared times that 1. E squared, just think of it like a number, like a 4 or a 2. Great. So after we do this, you should get this step. This is me just distributing, and this x plus 5 is by itself. Now, we're almost trying to solve for x. We're almost there. We need to bring the x's together, bring together the like terms. This quantity, I gotta move over here. Since this is a positive quantity, it's not a negative in front of it. It's not a negative right here. We're going to subtract both sides by e squared x. We do that, and we have this. Good, the x's are together, but this 5 right here, this 5 does not have an x, so I'm going to move it out the way. Let's move it out the way by subtracting 5 both sides. Good. And sorry I moved up ahead right here, but after I subtract 5 right here, what I did is I pulled the x here and here out. When I pulled it out, what's left over from here is an imaginary 1 minus and then e squared. And that 5 got moved over here. So that's how I got this. Great. Now this is x times this stuff in the parentheses. And I want to solve for x. So the opposite of multiplication is division. So I'm going to divide both sides by the stuff in the parentheses. So there we go. It looks like we've solved for x. So x equals this stuff. And I'm not sure if they want you to answer in decimal format or not. But this is how you solve for x in this equation. Please send back any questions if you have it. Let me know if you can hear the audio on this. Let me just